So here's a practice test for proving triangles congruent. So make sure you get this paper either from your teacher or you can just copy the problems in your spiral. So that way you can practice and be ready to take the test. Okay, so number 1 says, if ABC is congruent to DEF, find the measure of B. So remember when they make a congruent statement. So this right here is a congruent statement when they say what's congruent to what. Now remember that the order of these has to line up. So what I always do is I take both of these. So if I have the first one is written ABC, so I would write A, B, C. The second one is written DEF. So put that right underneath there, DEF. So this is going to tell you which parts match up to each other. So in this statement, it says that A lines up to D. So in our pictures, that's going to tell you that A, this angle right here, is going to be congruent to D, this angle over here. So you notice how this one says 65. So that means that D also has to be 65. So I'm going to put a 65 degrees right in here. Maybe I should. Let me try to put it off to the side. Write it a little bit bigger. 60. Oh my goodness, make pen. 65 degrees. Okay. Now, also, let's just keep looking at that. That means that angle BE, B and E are congruent to each other. So angle B is up on top here. I'm going to do this with a double arc. Is congruent to E. So that's up on top here. Now, neither of these have a measure inside them, so I can't really transfer any information yet. And then we have C and F. So angle C and angle F are congruent. So in my picture, angle C is over here. So I'll mark that with a little ticky. And F is here. Now it looks like angle F is 27 degrees. So since it's congruent to C, I could put a 27 over here. So that's 27 degrees. Now remember, all the degrees are angle measures inside the triangle. Now, what do we want to try to find out? We want to try to find out the measure of angle B. So we don't have any information about B up here, but we do know some things about triangles. So whenever you have a triangle, the sum of the interior angles, that means the 3 angles inside. So sum inside of a triangle. So sum is when you add them up, equals 180 degrees. So we can get our little calculator. So we have this 65 and this 27. So we have 65 plus 27. So far, inside this triangle, put in your calculator or add that up. 65 plus 27. That is a, what do we got here? 92. So if we want to have it add up to be 180 degrees, we need to figure out how much more we need this angle to be up here. So what do we need this angle to be up here? So we can just do 180 degrees minus 92, and that's going to tell us what the last angle has to be. So we have 180 minus 92, and that is 88 degrees. So that means that angle B, the measure of angle B up there on top, is 88 degrees. Okay, in order to check it, I would get my calculator out and just do all the angles inside there. 65 plus 88 plus 27. And ask yourself, does this equal 180 degrees? If you put in your calculator and it does, then check. It works out. Okay, question number 2. Do make sure you have all this written down. Oh my goodness. Question number 2. Struggling. I can't get my board to scroll. Okay. So we have triangle MNO is shown to the right. And here's triangle MNO over here. Boom, boom, Boom. Okay. It says, which triangle can be shown to be congruent to M and O with only the information given? So only the information given. We can't use anything else. Now, here's the thing. We have 5 ways to prove triangles congruent. What are the 5 ways? 5 ways to prove triangles congruent. You have those in your notebook. There is angle, side, angle. There is side, angle, side. There is angle, angle, side. There is side, side, side. And there's hypotenuse, leg, right angle. I'll put a little right angle symbol there. So these are the 5 ways you can use. There are no other ways unless these are like shortcut ways. Now, obviously, you can prove all 6 parts because remember there's 6 parts to a triangle. There's 1, 2, 3 angles inside. And then there's 1, 2, 3 side lengths going around the outside. So there are really 6 parts to a triangle, even though in your head you think a triangle is 3. It's really 6. Okay, so let's see if we have any of these things going. So I would recommend we check each one of these and see what information we have to see if we can get angle, side, angle, or side, 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 or any of these options over here. Because none of these have all 6 parts labeled. So we do not care. Okay, let's check this first picture out. In this first picture, option A, it looks like I have an angle right here because it says 60 degrees there. This 4.99 is for this side. So this is an S. And then this 4.6 goes on this side, right? So it looks like I have an angle and 2 sides. Now, when I look over here, an angle and 2 sides, what are my options here? This one here is the only one it might be, right? Now remember, if we think it might be side, angle, side, let's see if we think this is side, angle, side, because this is 2 S's and an A. Now remember the rule though, if you think it's side, angle, side, then that means, you see how both of these S's on the outside are touching that A. So you have to ask yourself, are both sides touching? I hope you're listening to me because this writing is horrendous. I don't have my stylus. So are both sides touching the angle? That's what you have to ask yourself. Are both sides touching the angle? So let's take a look at the sides. I will trace them in black. So one of my sides is right here, correct? Boom. Do you see how it's touching right into this angle? Do you see how that side touches it? So that one's good. But look at this orange side that I have over here and ask yourself, is this orange side touching this angle? No, it goes from here to here and it never touches. You know what touches means. So that means it's got to come right into this angle right here. Nope, that orange piece is not coming anywhere in there. So that means that I do not have side, angle, side on this picture. I actually have ASS, which we know is not a thing. So this one is out, does not work, because the only thing it could have been was side, angle, side, and nope, did not work. Okay, let's look at the next picture. In the next picture, the 70 degrees, that's a degree. See the little degree sign? That means that's an angle. This one is a degree sign. See it? That means that's an angle. This is a degree sign. That means this is an angle. So this is A. Huh, is that one of my options? Do you see an AAA there? Nope, not an option. No such thing. So that is not possibly it. Okay, let's look at this picture here. So let's see what I have on this picture. It looks like I have this 4.07. That is clearly on a side, right? I should just undo that. Okay, this is a side. This is a degree, so that is an angle. This is a degree, so this is an angle. So it looks like I have 2 A's and an S. So let's see over here. 2 A's and an S. Which ones have 2 A's and an S? This one and this one. So we got to check, is it angle side angle or AAS or nothing, right? So remember what we have to check for. So for ASA, think about how those letters are placed. ASA. That means that this side is touching both angles. I mean, just look how it's written. Do you see how this A is pretty much touching the S and that this A is touching the S? So is my side touching both angles? So let's look at my picture here. So this is an angle here, and this is an angle here. Now my question is my black side touching both of my pink angles? Is this black side is touching one of them, but is it touching the other one? No, this black side never ever comes anywhere near this pink angle, does it? So that means we do not have angle side angle. Okay, let's check, see if we have angle side. So if we're checking for angle side, that means you see how this side is sitting way at the end and is only touching this A, not the other A. So that means it's only touch one angle, only touching one angle. Okay, so let's look at our picture. Is it true that our side, look at our black side, is it only touching one of our angles? Yep, it's touching this angle and not that one. That's only one. And if you look, it's going to match up to these pieces because this 407 right here is right here. And then we have the 70 at the top matching. And then we have the 50 over here matching. So we do have, this one is congruent by angle, side. So this is a winner, winner, chicken dinner. This one works. Let's just check the last one just for the heck of it. So let's look at the last picture. So I got this 407, and that is clearly on a side, right? Use a different color. And then we have this 4.99, and that is clearly on a side. Is there any other information on this picture? No. It is only SS. Is SS one of our options over here? Nope. No such thing as just SS. Not enough information. Boom. So our answer choice would be C. Now remember, when you do multiple choice, they usually take longer than regular problems because you really have to do like 4 problems in one. When people ask you if you want a multiple choice test, say no. They're harder. All right, number 3. If we have angle ACB is congruent to DEF, so we're going to do the exact same thing and match them up. So ACB is congruent to FED. Do you see how I lined them up exactly how they said them right here? Boom, boom. And that means the A matches the F. So let's look at our picture. The A is up here, matches the F up here. So that means that this little piece up here is also 2x minus y because they match. Okay, next piece. We've got C and E match each other. So C is down here and E is over here. So this C is 108. So that means this E has to be also 108 degrees. And then we have B and D. So B is here. Angle B is 48. And angle D has to be 48 also. So there you go. Look at that. We just figured out what y was. So we know now that y equals 48. Easy peasy, lemon squeezy. Okay, what else do we have to? So we have to solve for x and y. So we need to figure out what this x is up here. So let's use some algebra. So we've got this. We know these two are equal. Now here's the deal. Remember, we have the same trick we had in number 1. You see how this is a triangle? And what is true about the sum of the inside angles of every triangle? So that means that all 3 inside here have to add up to be 180 degrees, right? So we have a 48 so far inside there plus a 108. And it wouldn't matter if I use this triangle or this triangle because they're the same. 48 and 108, 48 and 108. Let's see how much that is already. So let's add up 48 plus 108. That is 156. 156. So far we're up to 156 degrees. We need to get up to 180. So we need to figure out what the last angle has to be. So if we have 108, take away 156, how much is left? So 108, take away 156. Oops, not 108, 180. My bad. The inside is 180. I was writing this 108 again. So we need 180 minus 156. So that equals 24 degrees. So that means this top angle up here has to be 24 degrees, right? So that's telling us this 2x minus y has to equal 24. So this is going to be algebra. 2x minus y equals 24. So we have to solve this. Now here's the deal. We already know what y equals. So y is 48. So we could just plug that in. So we know 2x minus 48 equals 24. And we can solve this to figure out what this is. Remember, change this to plus negative. So to get rid of that negative 48, we have to plus 48 on both sides. And we're going to have 2x on one side, and on the other side, we're going to have 24 plus 48. And that's 72. Are we done yet? Very last step. How do we get x by itself? We're going to have to divide by 2 on both sides. So we have x is equal to 36. 72 divided by 3. So we have solved for x and y. And remember, we can even check it by plugging that back in. So we could think in our head 2 times 36, take away 48, and see if we get 24. That's how we would check our work. Okay, number 4 is just like number 1 and number 3. So you're going to have to do that one by yourself. So this is due on your own. You could show it to me, and your teacher will check it. Okay, this one here, you just have to match up the parts. So A to C to B, you have to name this one so it matches exactly. And then the second part, just down here, tells us to name what parts are congruent. For example, in this picture, we would see angle A is a right angle and angle P is a right angle. So one of our statements would be that the measure, angle A is congruent to angle P. That's one of them. Now we could also talk about sides. So if I look at this side, see this side is marked with a double tickies. Find on the other picture the side that's marked with a double tickies. This one right here, see double tickies? So that means that this side is congruent to this side. So when we write a side, remember, we use its 2 endpoints. So from B to C. So we write it like this, from B to C. Remember, like that, a segment is congruent to what side does that match over here? You would say Q to R. You can also say R to Q. It doesn't matter because remember, when you name a side, it could be forward or backwards. You just have to name it by its 2 ends. So segment, I'll just say RQ. Okay, so these are 2 of them. So this is 1. This is 2. These triangles have 6 parts. So you do 3, 4, 5, and 6. Okay, you do those ones. Make sure you show your teacher so we can check to see if they're good. Okay, I'm going to do a couple of these. Let's do a couple of different kinds. Okay, let's do number 6. Okay, so let's take a look at number 6. Now remember the 5 ways. There's angle, side, angle, side, angle, side, angle, angle, side, side, that's an A, side, 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 and hypotenuse, leg, right angle. That's an ugly right angle. Okay, so there are 1, 2, 3, 4, 5 different ways to prove that triangles are congruent. So these are your options for your theorems, postulates, okay? Now remember, you have to show that all these parts, so for each one of these, there are 3 things you have to label. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and even HL is 3 because you need a hypotenuse and a leg, and you need a right angle. So there are 3 things. So that means you're going to need at least 3 different colors. At least 3 different colors. If you don't have 3 different colors, then you're not proving 3 things. Okay, so let's look at this picture here. Okay, so you can clearly see the 2 triangles. Now, if you want to have 5 colors and color these 2 different ones, but I'm not even going to worry about coloring them right now. Maybe I'll put dots in the middle so you see the 2 ones. I'll talk about the yellow triangle and the pink triangle. Okay, so let's look and see what we have marked on here. So remember when they put matching arcs. See how this arc matches this arc. So they're telling you that those 2 pieces are congruent, and that's a given. Okay, so I'm going to pick my first color. I'm going to pick green. So I have this mark and this mark. Those 2 angles are congruent. So I'm going to put a little green dot. So this is my color coding down here. So green dot. So I do have 2 angles, right? And that is given, basically, right? Because it's given because they marked it in here for me. So that is my first piece. So look, see, I could have this A or this A or this A. That's about all I got, right? Because it's not a right angle. So far, I can use one of these 3 if I get some more information, right? Okay, let's see what else they marked in the picture. So they marked this box and this box. Notice how I use a new color, right? Because I'm doing my next thought. So I have an A that's given. Now I have this box. So what does this box mean? It means I have 2 right angles. If I have 2 right angles, then aren't they congruent to each other? Because this is 90 degrees and this is 90 degrees. So that means these 2 are congruent. So my second thought is I have another pair of A's, and they happen to be right angles too. But they are congruent and they are right angles. So I have a pair of A's, and that is also given. The reason it's given is because it's already marked for me in the picture. Remember, if it's already marked or they tell me in words up here, then it's a given. Okay, so I have 2 givens. Now, if I look at these pictures, there's absolutely no other marks on this, which means there are no more givens. Okay, so that means and I don't have enough stuff. I so far have 2 A's, right? An A and an A. So it could be this guy. Boom. It could be this guy, right? It can't be this guy anymore, right? It can't be this one because I have 2 A's. Okay. Let's see if there's anything else I have in this picture. Now remember that if you have a side or angle that's shared by both triangles. So I'm going to draw this side right here. This is a side, right, from A to D. AD is one of the 3 sides of my yellow triangle over here, and AD is one of the 3 sides of my pink triangle. So AD is congruent to AD because it's on this triangle and this triangle. So it's like 2 different sides, but it's really the same side. Now, those are congruent to themselves because every single thing in the world is congruent to itself. So I'm going to put an X on that. So I now have a side. Color coding. I have a side. Now, since it's not given, I need to put a reason. So the reason for this side is because it is the reflexive property. Remember, the reflexive property tells you that something is congruent to itself. So that's telling me that AD, side AD on my yellow triangle, is congruent to side AD on my pink triangle. So even though it's really only 1 part, it's really 2 parts because he's part of this guy and part of that guy, just basically on top of each other. So that is reflexive property. So you notice how I had to do reasons. So this right here is a reason. This right here is a reason, and this right here is a reason. And now I have three things. I have two A's and an S. So that means it could be this guy or this guy. It's not that one or that one or that one or that one, right? But I'm going to undo those because I'm going to reuse them. Okay, so I'm asking myself, is this going to be, could this be ASA or AAS? So remember what this talks about. This S has to be in between the two A's. So look at these two A's right here. Do you see how they're both touching this S? This A is touching it and that A is touching it. So we have to look at our picture. And when we look at a picture, we only look at one of the triangles. So we have to decide in your head, are you going to look at the yellow triangle or the pink triangle? I'm going to go ahead and look at this pink triangle over here. Okay, so everyone see the pink triangle? Okay, so only look at this pink one. And I'm going to make my lines be in black so you can see them. Or I'm going to, whatever we have. So we do have this angle over here. See him? He's marked. We do have this angle down here. See him? And we do have this side. Those are the only three parts of the pink triangle that are marked. This angle, this side. See? Angle, angle, side. Now our question is our side touching both of the angles? So is this black side touching both of my circled angles? This one and this one. Well, it looks like this side, he's touching this angle. But does this side ever come over here to touch this guy? No. So that means it is not angle, side, angle. Now this one says, you see how this S is only touching one of the A's. This S is not touching this A. So this S is just touching one A. So you have to ask yourself, is this side only touching one of the A's? Yep, this side is touching this A angle, but this side is not touching this angle at all. He never ever comes close over here, right? So we actually do have angle, angle, side. So these two triangles are congruent by the angle, angle, side, congruence postulate. So this is all the information you have to have. So notice I have my three parts all color coded in my picture. Now I kind of wrote in black over top so you would see what I was talking about when I was pointing, but you don't need that black when you're doing your work. Okay, let's see if we could try another one. So remember, only talk about stuff that you have. Let's go over to this one here. Okay, let's take a look. Now remember, let's do the easy givens first. Okay, so I am given that this angle is congruent to this angle, right? So that is an A. It also happens to be a right angle. So let's put that down because it could be just an A, like one of these A's, but it also could be this guy here, right? So I have one of my A's, and that is given, correct? Because they drew it in the picture. Okay. I'm going to mark my two triangles just so you can see. Well, I'll talk about my pink one and my yellow one later. Okay. Now I need my next part. Pick a new color. I'll do orange. Is there anything else marked in these two pictures? So you see this ticky mark and this ticky mark. What is that ticky mark on? It's on this side. So that side is congruent to this side because they have matching tickies. So we do have an S, and that is given. Given because there's marks on it. That says given. Sorry, my bad. Given. Okay, so far we just have an A and an S that are given. Do you notice there are no more marks? A pair of A's and a pair of S's. So I have an A and an S. Okay, now I need to see if I know anything else. And you're going to have the same situation you just had in our other picture. So you have this piece in the middle. You see this side? He's a side, right? From here to here is the exact same on both triangles. So this purple line is a part of my yellow triangle, and the purple line is also a side of my pink triangle. So I actually do have another S. Now, since it's not given because there's no mark on it, that's going to be, they're shared in between. Remember, that is going to be my reflexive property. I need a reason because it's not given, so I have to say why. Remember, if it was in a proof, on the right-hand side, you'd be writing given for this one, given for that one, and reflexive for this one. So it looks like I have ASS. Now, we do know ASS is not a thing up here, right? But two S's and an A. So my options for two S's and an A could be this, right? Two S's and an A. Or it could be this because I have a right angle, right? So let's check for SAS first. So if it was SAS, then that means that this angle, both of these sides are touching this angle. So both sides are touching this angle. Now remember, when we check for these, you're only going to look at one of your triangles. So we got to decide, do we want to look at yellow guy or pink guy? Well, we looked at pink guy last time, so let's go ahead and look at yellow guy. So I'm only going to be looking at this triangle down here when I look for SAS. So let's see. I'm going to go in black again just so you can see what I have. So it looks like I have this side, and I have this side, and I have this angle over here, right? Which happens to be a right angle. So my two black sides. Now remember, do you think that both of my black sides are both of them touching this angle? So is this black side touching that angle? So go from here to here. Did I ever touch this angle? No. Now this side down here, when I go from here to here, look it, I do touch it. So it looks like only one of my sides is touching. So two of my sides are not touching. So I do not have SAS. So this one is out of the mix. He's not that one. Now I need to see if I have a hypotenuse, leg, right angle. So let's quickly review. If you have a right triangle, remember wherever this is, the side across from it is your hypotenuse. And that's my hypotenuse. And that means that this is going to be a leg and this is going to be a leg. Now we also know we can further describe them with adjacent and hypotenuse, but these are two legs. So in order to have hypotenuse, leg, right angle, I need a right angle, I need to have the hypotenuse, and I need to have a leg, all marked. So in my picture, if I look at this yellow triangle, I already marked. In black is what I had down here, right? So let's look at, I'll do a different color here. So this is across from the right angle, correct? So he is my hypotenuse. So I do have a hypotenuse. Check, I got a hypotenuse. I have this marking down here. This is one of my legs, right? So I do have a leg, check. Do I have a right angle? Yep, this was a box in the corner, so I do have a right angle. So I do have hypotenuse, leg, right angle, and this is a theorem. Not like it really matters, but it is a theorem. So these two triangles are congruent by the hypotenuse, leg, right angle theorem. And I have my three things color-coded with reasons, given, given, and reflexive. Now, if you're in my class, I told you didn't have to write the word given. I could see it in the picture, but you do have to write reflexive. Now, if it helps you to put your statements by each one, then do that, because that way you have always a statement and a reason, and you mark it in that color. So everything's color-coded. And it's hypotenuse, leg, right angle. Remember, you need all these parts to get full credit. I'm going to do about two more. Let's do this one down here. No, let's do this one first. Okay, so this one has some things that we have not seen yet. So if I look at this, it looks like I do have a segment. So do you see this tick mark? Matches this tick mark. So that's telling me from here to here, is congruent from here to here. So that is a given because it had the tick marks. So I do have a side that is clearly on a side, right? If it's the tick mark in the middle, remember if it's at an angle, it's going to have a little archy, right? So I do have a side, and that is given. Now, if I look at this, I don't have anything else over here. There's no other markings, which means there are no more givens. So anything else I get, I better have a reason besides given. So you can't just color and be like, oh, I think this side matches that side. No, you don't have any reason. But I do have something else. So remember what these symbols mean. These symbols mean that these lines are parallel. If and only if you have parallel lines. Remember what I suggested. If you have parallel, meaning you have little arrows, right? See the arrows? Then you should look for the Z. Look for the Z where the parallel lines are the top. Oh my goodness. Undo. The parallel lines are the top and the bottom of your Z. So if the top and the bottom of a Z are parallel, and you remember you're allowed to turn him upside down or sideways, it doesn't even matter. So if the top and the bottom are parallel, then you can get alternate interior angles inside the cracks of the Z. So that would mean that this angle is congruent to this angle. So whenever I see parallel, and only if I see parallel, they have to tell you it's parallel, otherwise you can't look for a Z. So don't even start looking for it. Because over here, look at this picture. Can you see a Z in it? I see one from here to here to here to here. But do you have any parallel markings on this one? These are not parallel. These are not parallel. There's no marking on here that tells you that they're parallel, so you can't use it. So these are not parallel, so no Z. Don't look for a Z on this one. According to all these pictures, this one over here is the only one that has these. So since they're parallel, we're going to look for a Z. So I'm going to do a Z in a different color. I'll do him in this green. So I see two Z's. I see a forward Z from here to here to here. And I also see a backward Z from there to there to there. Wait, did I do that? That was forward. And this one's, I forgot. Yeah, this other one's backward. I could use whichever one I want. I could actually use both. Let's just use one of them. I'm going to use the one from here to here to here. Do you see the Z? As long as the top and the bottom of my Z are the parallel lines, then I could use it. And that means the angles in the crack of my Z are congruent to each other. So in the crack of my Z is this one and this one. Those are inside the crack. So that is an angle inside the crack of my Z. And those, remember, are called alternate interior angle theorem, or alternate interior angles are congruent. And that's only because we had parallel. So I have that. So I have an S and an A so far. Now remember, I said I could use the other Z, but I got another thing I could use. Remember, if you have an X, you can also use vertical angles. So it's up to us. We could decide. I could use my other Z, or I could do the X, just so we mix it up. I'm going to use the X instead. So look here. I'm going to make my X in orange so you can see it. See the X in the middle of the picture? Do you notice that on this side, opposite sides of my X, you see how I'm marking them with an arc with little ticky on them? These are opposite sides of an X, right? Now it's true that this angle and this angle over here and over here are also congruent to each other, but over here is not even part of my triangle, so I can't even worry about that. So I'm going to worry about this top guy and this bottom guy, and that's going to give me another A. Now remember, I need a reason because it's not given, because those marks were not there. I made them. And the reason is because vertical angles are congruent. So I'm going to say vertical angle theorem, or vertical angles are congruent. I like to always throw the congruent in the end just because I always remember the congruent. So it looks like I have an S, A, and A. Now remember, I didn't write my things up here. Now what are my options? I had some things that had S, A, A. It could be an ASA, right? It also could be an A, S. I have to see if my S is touching both of my A's or if my S is only touching one A. Because if it's this first one, that means the S is touching both A's. You see how these two A's are both touching this S? So I'm going to do them in black. Now remember, you can only look at one triangle, right? So I can look at this pink guy up here or this blue guy down here. Let's go ahead and look at the blue guy down here. Let's see what we had marked on the blue guy. So it looks like I had a marking on this because of that tick mark, right? It looks like I had this angle right here. It looks like I had this angle up here. So these three black marks are what I have here, a side and an angle and an angle. Because remember, I only look at one triangle to check these. Okay, so my question is my S touching both of my A's? So this is my S. You see him down here? He certainly does scoot over and touch this A, right? But does he touch this A up here? Does this side ever come into this angle? Nope, it does not. So it is not that one. Now the second option is that your S is only touching one A. Is this S just touching one A? Yep. So this is it. Winner, winner, chicken dinner. So these two triangles are congruent by the angle, side, congruence postulate. Okay, so there are other ones you should do. Now, if you take a look at this. Remember, you see how this side is going to match that side, so that's one S. This side is going to match this side, so that is two S's. Those are both givens, right? There's nothing else marked on this, right? But think about, are we allowed to use a Z in this one? Do we have any parallel lines? Are there any parallel lines? No, so we can't look for a Z. But what can we look for that we looked over here? Do you remember this X? What was the X? Angles on the opposite sides of an X are vertical angles. So if you look at this, we do have an X. So we can get some vertical angles here and here. That's going to work out, right? Okay, so there are problems that you should do yourself. So ones you should do yourself. Obviously, number 4. Number 5, finish 5, we started it. Then you have 7, 8, 4, 5, 7, 8, 11, 12, 13. So you should be doing 4, 5, 7, 8, 11, 12, 13. So after you get a blank sheet of this, or you could write this and do these in your notebook after you have these checked during your lunch period or during after school time, then we can talk about possibly getting a score that can see if we can earn a score to get a passing grade for your test.